Quercetin is a plant flavonoid which is found in many fruits and vegetables, including onions, kale, and grapes. Quercetin is an antioxidant, and it also has anti-inflammatory properties as well. And this is because it can prevent the release of certain chemical factors from mast cells. I'm going to try and extract quercetin from the skin of onions. I'm going to be taking these skins from these onions. These onions were grown in Suffolk, UK. I don't think there's anything particularly special about Suffolk onions. I do have some other onions which I have the skins from, which were used for cooking. I don't want to take the skin off of too many onions at once, because obviously once the skin has been taken off of an onion, then it can only last so long. I'm taking the onions out of the bag, and I'm just going to start peeling the skins from the onions off and keeping them separately in a pile to the side. Sometimes the onion peel will come off in big chunks like this, but other times it only comes off in tiny little amounts and it can take quite a long time. One thing that is different though is that I am only really interested in getting this dry brown onion skin, and I'm not interested in getting this green stuff because it contains a lot of water. After peeling all of the onions and combining the skins with the onion skins which I'd already collected, I'm going to weigh out the onion skins, and it looks like I've got about 40 grams. Next I'm going to rip up the larger pieces of the skin into smaller pieces, and this will help to fit them into a flask. Now that I've packed and weighed the conical flask, I can tell that it was able to fit about 25 grams of dry onion skin. If the skin was a powder, it would be able to fit a lot more because most of the volume inside the flask at the moment is just air, but it's quite difficult to turn onion skin into a powder. To do this, you would probably need a steel ball mill or some other way of turning it into a powder. So for now I'm just going to go with the onion skin as it is, and the extraction might take a little bit longer, but we should get something nonetheless. To the flask I'm adding a starting volume of 500 milliliters of ethyl acetate. I have made ethyl acetate in the past, but I didn't make much more than about 25 milliliters. So for this scale I needed to buy some online. Procedures online suggest that you can use different organic solvents, but ethyl acetate has shown to reduce the amount of impurities in the solution. One paper in particular used ethanol as their solvent, and they ended up with an oily crude mixture instead of quercetin as a solid powder or crystals. Looking at the flask, I can tell that I can add some more ethyl acetate, so I'm going to add about another 300 milliliters. The next step is to set up the flask on a reflux, so I've put it onto a hot plate and connected a condensing column vertically above the flask, which has cold water going through it. The way that the cold water condenser is being supplied is with this bucket of ice water and a fish tank pump to push the water through the tubing. The boiling point of ethyl acetate is about 77.1 degrees, so as the solution warms up we should begin to see some bubbles forming and eventually the vapors beginning to condense back into the flask. The increased temperature of the solvent should improve the solubility of quercetin in the solution and allow for a more effective extraction. I'm also hoping that in boiling the solution it will help to break down some of the structures of the onion skins and release the chemical compounds inside. As the boiling progresses, the solution is also beginning to take on a little bit of a yellow colour. Refluxing is when you boil a solution directly under a condenser so that you can have the elevated temperatures of a boiling solution, but you don't lose any of the solvent to evaporation. I'm going to leave this solution to reflux for about 2 hours, and then I'm going to come back and hopefully the solution should contain enough quercetin for a successful extraction. After allowing the solution to reflux, I'm pouring about half of it into a 2-neck round bottom flask. The reason that I'm using a 2-neck round bottom flask is because I want to recover as much solvent as possible, but I don't want to boil all of the solution at once and risk it boiling over. In order to recover the ethyl acetate solvent and to obtain an onion quercetin extract, I've set up the solution in the 2-neck round bottom flask in a simple distillation setup. The heating mantle will boil the solution in the flask, and the vapours of the solvent will travel up into the still head and be recondensed into the ethyl acetate bottle. Meanwhile, any non-volatile compounds such as quercetin, which have been dissolved in the solvent, should remain in the flask. As more and more of the solvent is recovered, once the solution begins to get low in the flask, I can wait for it to cool down, unstop the left arm of the flask and add more of the solution to keep boiling. As the solution boils, I'm also being careful because ethyl acetate vapours are actually more dense than air. This means that the vapours can flow along work surfaces and across the floor, and if they reach a point where there's a heat source or there's sparks, then it can ignite, and so I've got a fire extinguisher handy. Now all of the solution has been added and most of the solvent has been boiled away. A yellow-brown solid has begun to separate out on the sides of the flask. What this looks like is that as the solids have come out of solution, some of them have oxidized on the hot surfaces of the walls of the flask. I'm going to try and get as much of this stuff out of the flask as possible and then try and purify it. Using a small amount of ethyl acetate, I was able to get most of the solids out of the flask into this beaker. There appears to be two main components to the solids which were in the flask. The first is this dark brown or black tar-like substance, which remains as a solid in suspension in the solution. And the second is this yellow solid, some of which has come out on the side of the beaker. Therefore, to separate them, I'm just going to try and dissolve as much of this yellow solid in ethyl acetate as I can, and then filter off the solution, and try and remove the solvent more gently to prevent any of it oxidizing. I'm simply just going to filter the solution straight onto a watch glass. The insoluble black stuff should remain in the filter paper, and the soluble yellow quercetin should filter through in the solution to the watch glass. The watch glass should act as an evaporating dish, and I should be left with some solid quercetin once the solvent has evaporated. Once all of the solvent has evaporated, I'm left with this small pile of yellow-brown powder. According to the literature online, this powder should contain about 60 to 70% quercetin, but I'm going to try and purify it by a recrystallization. I'm going to do the recrystallization with ethanol, and this should hopefully remove some of the impurities. After attempting a recrystallization of the solid with ethanol, I'm left with this much cleaner looking yellow powder. Quercetin isolates online are often described as a yellow or dark yellow powder, and so I think this matches the description pretty well. In total, the amount of quercetin extracted from the onion skins was 0.62 grams. This, as with all of the bioactive compounds and substances which I extract or make, I do not intend on ingesting it, and this is because the glassware which I used has been used for other toxic compounds, and also some of the solvents are toxic or irritants. It is, however, really fun to explore the science of extracting compounds from natural sources, and there are a lot of industrial processes out there which can extract such compounds in a way that makes them food safe. This compound is also interesting because it can have a significant impact on health by way of being an antioxidant and anti-inflammatory agent, and it comes from something which is just a waste product, which is the skins of onions. As mentioned before, quercetin is a flavonoid compound which can be extracted from lots of other different sources of fruits and vegetables, but it's a useful compound which can be extracted from something which was going to go to waste anyway. If you enjoy science or chemistry, feel free to subscribe to my YouTube channel. I'm looking to do some more organic synthesis soon, and perhaps some inorganic chemistry too.